Section: Introduction. In this section, we delve into the exploration of the lost in the middle problem in language models. We aim to understand why models struggle to find relevant information placed in the middle of the input sequence. Our study follows the original experimental setup using an open domain question answering task. We set up the scenario where a model is given a user query and a set of related documents from an external source. Among these documents, only one contains the correct answer. The input sequence for the model includes the question and the documents, with the model generating the final answer. It has been observed that the model's performance notably drops when the correct document is positioned in the middle of the input prompt, compared to when it is at the beginning or end. To gain deeper insights into the model's errors, we replicate the lost in the middle phenomenon using a Vicuña 7BV 1.5 to 16K Vicuña model with a total of 20 documents. Our focus is on analyzing errors made by the model when the correct document is placed in the middle position, 10th, of the input sequence. Section Summary. In this section, we delve into the challenge of the lost in the middle problem in large language models, LLMs, when retrieving relevant information from external sources. We investigate how the intrinsic attention bias of LLMs, favoring the beginning and end of input prompts, contributes to this issue. By introducing an attention calibration mechanism called found in the middle, we show significant improvements in LLM performance on retrieval-augmented generation tasks, suggesting that LLMs may indeed be capable of capturing mid-sequence context but are hindered by positional biases. Section: U-shaped attention bias. In this section, we examine how our model responds when gold documents are placed in the middle of input prompts. We notice that the model tends to focus heavily on the document at the first position, regardless of where the gold document is located. This bias remains consistent even if the order of the input documents is changed. Quantitatively, the model's response is strongly influenced by the document at the first position, even after shuffling the document order. To measure this dependence, we calculate the similarity between the model's response and each document using TF-IDF. To understand the origin of this positional bias, we analyze the model's self-attention weights, which have been shown to relate to the model's outputs. We define a function that computes the average attention weights assigned to each document in the input prompt. By visualizing these attention weights, we observe a U-shaped pattern where documents at the beginning and end receive higher weights compared to those in the middle. Importantly, this U-shaped pattern remains even after shuffling the document order, indicating that the bias is not influenced by the actual content of the documents. Observation 1 shows that the model prioritizes relevant contexts from the same position. When comparing examples with the original document order to randomly shuffled order, we see a significant difference in attention values for specific documents. The model tends to give higher attention to relevant documents, especially when they are in their original position. Observation 2 suggests that the model prioritizes documents with higher attention weights for generating its output. The model is more likely to include the document that receives the highest attention, often the one at the first position, in its response. Based on these observations, we propose that the positional attention bias significantly influences the model's reliance on documents at specific positions during output generation. The model's tendency to use documents with higher attention weights correlates strongly with the positional bias. To address this issue, we aim to model and mitigate the positional attention bias so that the model can better utilize the full context window without favoring certain positions. We identify two main factors that drive the model's attention: the document's position within the input and its relevance. Section Summary. In this section, we analyze the U-shaped attention bias in models when responding to input prompts with gold documents. We observe a strong bias towards the first document position, regardless of the gold document's location, both qualitatively and quantitatively. This bias persists even after shuffling document order, indicating a significant influence on the model's response generation and suggesting a need to model and mitigate positional attention bias for more effective utilization of input context. Section: Our hypothesis. In this section, we consider modeling the attention weights assigned to each document in an input based on its relevance and positional bias. We use a function that increases with both relevance and bias. To simplify, we use attn x_doc_k to represent the attention given to a document at a specific position in the input. To validate our model, we conducted experiments with 20 documents using the natural question dataset and a specific model. We set conditions where attention increases with bias when relevance is fixed, and attention increases with relevance when the position is fixed. We tested these conditions on 100 examples and found that they hold true in a high percentage of cases, supporting our hypothesis. Our aim is to separate positional bias from model attention so that the model can focus on relevant information regardless of its position. While we have shown that the function f increases monotonically, we still need to determine its exact form to eliminate positional bias. We tested a simple linear model to approximate f and found a strong correlation, indicating its effectiveness despite its simplicity. Therefore, we adopt this model for now and leave exploring more complex alternatives for future research. By using a simple form of f, we can remove positional bias from model attention. We can calculate the true relevance of documents by comparing their attention values with a reference model attention obtained using a dummy document. This process, known as calibration, helps us isolate and eliminate positional bias from the attention mechanism. Section Summary. In this section, we propose a model to analyze attention weights allocated to documents in a given input, considering relevance and positional attention bias. We conduct experiments to validate our model's conditions, showing that attention increases with bias and relevance. By using a simple linear model to approximate the unknown function in our model, we successfully disentangle positional bias from model attention, allowing us to accurately assess document relevance. Section: Calibrated attention finds relevant contexts in the middle. In this section, we explore how calibrated attention helps us identify important information in the middle of a text. By using calibrated attention, we can estimate and rank the relevance of different documents within a given input. To test our model, we use calibrated attention to reorder documents in response to a specific query. We conduct our evaluation on the natural question dataset using the Vicuña model, focusing on a challenging scenario where the key document is located in the middle of the input. We compare our model with 3 others: vanilla attention, query generation, and relevance generation. Our results show that calibrated attention significantly outperforms vanilla attention and performs better than the other 2 re-ranking methods. This confirms that our approach is effective in helping language models find relevant information, even when it's hidden in the middle of the input. After confirming the effectiveness of calibrated attention in locating relevant information within long texts, our next goal is to use it to address the lost in the middle issue and enhance a model's performance. To achieve this, we propose adjusting the model's attention based on the relevance of the context rather than positional bias. This adjustment involves redistributing attention values based on the relevance of each document, ensuring that more attention is given to the most relevant parts. We then evaluate our attention calibration method on 2 question-answering tasks, natural question and SynthWiki, using different models with varying context window lengths. Our experiments demonstrate that found-in-the-middle attention calibration consistently outperforms the uncalibrated baseline across different tasks and models, particularly in scenarios where the key document is in the middle of the sequence. In practice, one common way to address the lost-in-the-middle problem is by rearranging document positions based on their relevance. However, this method heavily relies on correctly ranking the documents. We aim to validate whether applying attention calibration on top of reordering methods can further enhance model performance. Section Summary. In this section, we introduce calibrated attention to estimate and rank document relevance within an input prompt, focusing on scenarios where the gold document is in the middle. By redistributing attention based on relevance rather than positional bias, our proposed method consistently outperforms vanilla attention and other re-ranking metrics, showcasing the effectiveness of our approach in locating hidden information. Through experiments on multi-document question-answering tasks, we demonstrate that attention calibration significantly improves long context utilization, offering substantial performance gains across different datasets and models, especially in challenging scenarios where the goal document is mid-sequence. Section: Attention calibration improves existing RAG pipelines. In this section, we explored how attention calibration enhances existing RAG pipelines. We evaluated using natural question and SynthWiki datasets and compared different reordering methods. These methods include prompt reordering, long LLM lingua R_K, and attention sorting. We observed that prompt reordering and long LLM lingua R_K are not affected by the position of the goal document in the sequence. Reordering methods help address the lost in the middle issue, where model performance improves when the goal document is in the middle. By applying attention calibration on top of long LLM lingua R_K, we consistently achieved the best performance across datasets and models. This suggests that attention calibration can significantly enhance models' context utilization, complementing reordering methods to enhance the RAG pipeline. Retrieval Augmented Generation, RAG, is a framework that leverages external knowledge sources to assist language models in generating text. While LLMs have strong capabilities, they struggle with knowledge-intensive tasks. Recent studies have shown that LLMs face the lost in the middle problem, limiting the effectiveness of RAG. We delved into this issue from the perspective of attention bias and proposed attention calibration as a solution to enhance existing RAG frameworks. There have been efforts to enable LLMs to handle longer input contexts, such as improved training schemes and inference methods. However, models trained for long contexts still face the lost in the middle problem. Existing solutions manipulate input contexts but do not fundamentally improve ILM's ability to utilize long contexts. Our approach directly enhances ILM's long context utilization to mitigate the lost in the middle problem. The attention mechanism, particularly self-attention, has played a crucial role in transformer models' success. We introduced attention calibration to address positional attention bias, allowing LLMs to focus on context relevance rather than position. Experiments demonstrated that attention calibration improves model performance, especially when relevant context is in the middle of the input. Additionally, we showed that attention calibration can enhance existing reordering pipelines to further boost model performance. We acknowledged the limitations of our approach in simplifying the mechanism behind positional attention bias. While our hypothesis and attention calibration have shown promise, the true mechanisms driving attention bias may be more complex and adaptive than our current model considers. Section Summary. In this section, we explore how attention calibration enhances existing RAG pipelines, evaluating against methods like prompt reordering and long LLM lingua R_K. By addressing the lost in the middle issue through attention calibration, we observe improved performance in long LLM lingua R_K models, indicating that attention calibration can significantly enhance context utilization and complement reordering methods in RAG pipelines. Our approach focuses on mitigating attention bias by calibrating the model's attention mechanism, allowing LLMs to better attend to relevant context rather than just positional information, ultimately improving model performance, especially when crucial context is in the middle of the input. Section: Computational Overhead. In this section, we discuss the computational overhead of our method for calibrating positional attention bias. We acknowledge that our approach adds extra computational burden, requiring additional model forward passes to calibrate attention at each position. Despite this, our goal is to uncover and adjust the positional attention bias scientifically, paving the way for future research to develop more efficient calibration methods. We aim to eliminate positional attention bias entirely with our method. However, it's worth noting that this bias could actually be advantageous in certain situations. Depending on the task or data nature, models naturally focusing more on the input's beginning and end may align well with the task structure. Therefore, it's crucial to understand the specific tasks and contexts before implementing our calibration method. Although we strive to understand the relationship between the lost in the middle issue and the intrinsic attention bias in large language models, LLMs, the exact cause of attention bias remains unclear. Factors such as the pre-training corpora distribution, transformer model design, and optimization process could contribute to this bias. Further research is needed to delve deeper into the origins of this phenomenon. In our research, we concentrate on enhancing large language model performance using publicly available datasets, ensuring no personal or sensitive data is collected or used. Our attention calibration method aims to enhance the efficiency and accuracy of retrieval augmented generation, benefiting various domains like search engines and question answering systems. While our technique leverages pre-trained language models, potentially inheriting existing biases, we do not identify any immediate risks beyond this concern in our methodologies or findings.